Now we're going to learn about the relationship between a function and a derivative. So we have the graph of a function, and what we're going to be looking at is where the function is increasing, where the function is decreasing, and where it has a local maximum or minimum. This is the derivative of the function. You'll notice that this is a cubic function, and this is a parabolic function, quadratic function. So that makes sense because of the power rule. So first we're going to try and look at where the function is increasing. And you'll see that from our graph only goes till -5, but this function from -infinity to about -2.5 is increasing. And then also from about 0.5 to infinity is increasing. Increasing means that the slope of the function is positive. So now we're going to take the graph of the function away and put the graph of the derivative on top of it. And you'll notice that exactly where the function was increasing, which is inside the blue boxes, the derivative is positive. So that's an important relationship, that the derivative is positive whenever the function is increasing. Now we're going to look at where the function is decreasing. So you see in that red box is all the area from about -2.5 to about 0.5 on the x-axis, is where the slope of the function is a negative value, or where it is decreasing. So now we're going to do the same thing, fade out the graph of the function, and bring in the graph of the derivative. And you'll see that inside that red box, that is exactly where the derivative is negative. So when the function is decreasing, the derivative is negative. Now we're going to look at when the function has a local maximum or minimum. You'll see a maximum at about -2.5. That means that the slope of the function is changing from positive to negative at that point. And we have a local minimum at about 0.5, which is where the slope of the function is changing from negative to positive. Now again, we're going to take out the graph of the function, put in the graph of the derivative, and at first you'll say, alright, nothing seems to line up. But now we're going to move that line down to the x-axis, that circle down to the x-axis, and move this circle up to the x-axis. And you'll see that when a function has a local maximum or a minimum, the derivative is equal to 0. So that is our third relationship, that the derivative is 0 when there is a local maximum or minimum on the function. So in conclusion, we have three relationships. First one is that when a function is increasing, when it has positive slope, the derivative is positive. Secondly, is that when a function is decreasing, when it has negative slope, the derivative is negative. And thirdly, that when a function has a local maximum or minimum, the derivative is 0.